Okay, chapter 2.2, Introduction to Functions. Okay, the functions means, okay, we gotta know the definition of functions. Okay, let's say, okay, function means this one. Okay, whenever there is input, let me draw a little diagram like this. So I'm gonna put an input, usually something like this, we write a function like this, f of x equals, okay, 2x plus 1, for example. Okay, this means x is the input. So whenever we give a value of x, then we evaluate the right side of the equation, right? Evaluate it, then assign it to this guy. So this is the output. Okay, this is the what? Output. Okay, usually, usually we use, y equals something, right? Y equals 2x plus 1. So this will be the output, right? Output. And then instead of using y, we can use function name f parenthesis x. So this x means the input, and the f is just the name of the function. All right, so we will give one x value. Okay, let's say x equals 1. Then if it goes there, so 1 goes there, right? 1 goes there. And then the right side of the equation is this expression. So this will evaluate, so 2 plus 1, so 2 times 1 plus 1, then the result is 3, right? So 3 will be the output, 3 goes out. So x is 1 and 3 will be the output, which is the y value, the y value. So whenever you put one input, then you get one output. Okay, you cannot have two outputs. So the definition of a function is really simple. You provide one input, then you get one output. Okay, that's it. So for one input, you get only one output. That's the definition of function. Okay, definition of function. All right, so how about graphic notation? How about this one? Set notation. Here is the input values, and this is the output values. So you have 1, 2, 3, for example, and output is same as 1 or 1, 10, 20, something like this. And for the input 1, it goes here. For input 2, it goes here. Input 3 it goes over there. Then is this a function? Okay, the relation is, let's say, f of x. Is this a function? This is a function because, look at this. One is an input, right? One input, and this one input goes to one output, right? One output. So one has one output, and the value 2 has one output. No matter what the value is, it has only one output, right? Even 3 has only one output. So this is a function. But if we have something like this, 1, 2, 3, 1, 10, 20, this one goes here, and this one goes here, this one goes here. Is this a function? This is not a function because, as you see this, now this input, the input 1 has two output, right? Two output. It must have only one output. So because of 1, it cannot be a function. Can you see it? How about this? Now 1, 2, 3, 1, 10, 20, and everything goes to 1. Is this a function? Yes, this is a function. Because as you see this, each input has only one output, no matter what the output is. Okay, no matter what the output is, each input value has exactly one output. All right. How about this? How about in graphic? Okay, x-axis, y-axis. Okay, graph looks like this. This is a function? This graph is a function because this is a function. Because for each input there is 1 point. 1 point means there is one output, one y value. If x is over here, then also this point has one output, right? Even this point has, okay, when x is this is the point, and then this point has one output. So if you have a graph, then draw a vertical line. We call it a vertical line test. Draw a vertical line. And if the vertical line contains only one intercept, then that is a function. Okay, this is a function. So vertical line test. Try vertical line test. Vertical line test. Which means if there's a one intersection on the graph, then that is a function. Okay, one intersection. You may not cross this at one point. Then it is a function. Okay, so how about this? Okay, here's x-axis and the y-axis. If the graph looks like this, is this a function? Oh, of course it's a function, right? Of course it's a function because, draw a vertical line. Draw a vertical line, then it meets at one point. It meets at one point, right? So this is a function, but next one is not a function. This is a function. And next one is this. Okay, here one, y-axis. Okay, how about this graph? This is not a function. Why? Because once you draw a vertical line, look at this. There are 2 points. That means there are 2 outputs, right? So for this value x, let's say this is 1. For x is 1, then you have 2 points, which means there are 2 y values. So this is not a function. Not a function. Can you see it? Okay, so if there is a function, then always check the x values. So x values, then there should be only one y value. All right, and then let me explain this one again. Okay, input and output, right? So here is f of x equals f of x. Okay, let me explain it again. F of x equals, let's say, 2x plus 1. Then we know that x is the input, right? X is the input. Okay, x is the input. And then once you calculate this, then this will be the output, right? Output. All right, or we can use it, write it like this: y equals 2x plus 1. It's the same thing, isn't it? This is the input, and this is the output. All right, then the input variable. We call the input variable. So the output depends on what? Depends on the input. Input. What do you mean by this? This means the output, which is y, right? Y. And the input is the variable x. So the y depends on the input. So y is called, y depends. So y is the dependent variable. Dependent variable. And x is called what? Independent variable. Independent variable. Can you see it? So there are names for the input variable x and the output variable y. So the output depends on input. So output variable y depends on input, so that y is the dependent variable. And in other words, x is the independent variable. Okay, so keep in mind the definition of these variables. Okay, example 1 states whether the relation defines y as a function of x. Okay, y as a function of means y is the y equals something, so y is the dependent variable and x is the input variable. All right, then as you see this, okay, this is an order pair, so this is the x value, right? X value, and this is the y value. So from this, when x equals 2, y is 1, right? when x equals 2, y is 1. Okay, this is x and y. And for this one, x is 4, then y is 1. Okay, this one goes there. Even look at this. X is 4, then y goes 5. For the input value 4 has 2 outputs, so this is not a function. Okay, not a function. So we cannot define, in this case, we cannot define y as a function of x. Okay, next one. For this, if we rewrite it, then y equals negative 3x plus 1. Isn't this a linear equation? Linear equation is a straight line, right? Straight line. So there is, for each input x, there is only one output, right? The graph looks like this. The graph looks like this, right? So, of course, this is a function. Okay, how about next one? Okay, let me rewrite it. So, okay, y squared equals 4x squared plus 9. Okay, move this one to the right. Then if we remove the square, then this will become plus or minus square root of 4x squared plus 9. Okay, look at this. This means there will be two values. One is positive square root, and one is negative square root. So there are two y values, isn't it? So for example, let's say x equals 1. Then y equals plus or minus square root of 1. So 4 plus 9 is 13, right? So y is positive square root of 13, or y equals negative square root of 13. So for one input, there are two outputs, right? Two outputs. So this is not a function. Can you see it? Cannot have two outputs. Okay, now let's try this example. Okay, this is domain X. This is a set of input values, a set of output values. And then X1 matches here. And then X2 goes Y2. And then X3 goes to Y1. This one goes to Y1. And X4 goes to Y4. And then finally, X5 matches Y3. All right, then is this a function? Of course, it's a function, right? Because each input value is connected to only one output, right? Only one output. So this is a function. Okay, next example is evaluating f of x. Okay, evaluate means we're going to find the value. So as you see this, x is the input, right? X is the input. So f of negative 5 means, this means this negative 5 is the input. This is the input. So we're going to replace x with negative 5. Okay, so replace x with a negative 5. So what we're going to do is plug in negative 5 for x. Can you see it? So that equals 25 minus 1, so 24. Simple, isn't it? Very simple. So f of 3b. 3b means the x value will be 3b. So substitute 3b for x. So x squared, the equation is x squared minus 1, so x will be 3b, put parenthesis because we're going to square this 3b. Make sure to put parenthesis, then minus 1. That is 9b squared minus 1. All right, let's try another one. 3f of b. Okay, 3 of f of b means 3 times, right? 3 times f of b. So x value, replace x with b. So I'm going to put parenthesis because f of b is an expression x squared minus 1. And then put b, so b squared minus 1. So that equals, now distribute, so 3b squared minus 3. Can you see it? Replace. So, okay, let me rewrite here. Replace, right? Replace x with the input value, with the input, which is, in this case, -5, right? -5. All right. We do the same thing. F of a plus 3. Okay, then a plus 3 is the input. So x will be replaced by what? X plus 3. A plus 3. So x squared. So we're going to put a parenthesis and a plus 3. So this expression, this is the input. So this will be squared minus 1. Then we can do this one. Okay, using do you remember a formula? A plus b squared equals, this is binomial squared. Then square the first term plus 2 times first term, second term, plus the second term squared. Okay, so a plus 3 squared is the first one squared, and then multiply 2 terms by 2, so 2ab, right? 2ab, so that will be plus 6a plus 3 squared minus 1. So that will be a squared plus 6a, 9 minus 1, so plus 8. All right, how about next one? Okay, next one is f of a plus f of 3. Okay, look at this. We are adding two y values. Okay, two y values. So the first y value will have the input a. So let's use plug in a squared. So a squared minus 1. Okay, this is, what is this one? This is f of a, right? F of a. And then for f of 3, 3 squared minus 1. This is f of b, right? F of 3. Then we can remove the parenthesis. And the second part is 9 minus 1, right? So this is equal to a squared. Okay, so 8 minus 1 is 7. Can you see it? So first we need to get the y value when x equals a, and then get the y value when x equals 3. Then once we get the y values, add those two. Okay, the domain definition. The domain of a function means, okay, this is a set of all real numbers of x values and input values for which the function makes sense, and the function yields the real numbers. Okay, this means that whenever you give an input, you must have real number y, okay, output, real numbers. So if the y value is not a real number, like a goes infinite number, then that x value is not a function. So look at this. F of x squared. You know, x squared, we know the graph, right? The graph of x squared is, it looks like this, right? So this graph goes all the way up. So as it goes up, the x value goes to the right infinitely. As it goes to the left, the x value goes to the left infinitely, right? So x can be any real number in the number line x, any real number. So in that case, the domain, okay, let me say domain. So domain is all real numbers, right? All real numbers. Because there is no restriction in the input. But the next example is 1 over x. Okay. If we have a fraction, then we know, okay, as a common sense, we know that the denominator cannot be equal to 0, right? The denominator cannot be equal to 0, because if the denominator is 0, it's undefined, right? Because it's undefined, so there's a restriction in this case. The denominator cannot be equal to 0. So other than that, x can be any real numbers, right? So x is all real numbers, except what? Except x equals 0, right? Except x equals 0. So that is the domain. Can you see it? So when we see the function, we always need to find the x. The domain means those x values that make sense. All right. How about the next one? F of x equals square root of x. Square root of x is, okay, always this one, we call this a radical. Under the square root, this guy has to be always greater than or equal to 0. So this will be a real number. Okay, so square root of function, the graph of square root of function, square root of x is like this. This is x, x is y, x. If x equals 0, then y is 0. X equals 10, 1, then y equals 1, right? X equals 4, 4, then y equals 2. So the graph looks like this. So as you see this, x cannot be a negative number. Can you see it? X cannot be a negative, which means the expression under the s square root has to be greater than or equal to 0. Always, always. So the domain is, okay, x is greater than or equal to 0. The expression inside the square root. So depending on the function, the domain is different. So let's try some examples. All right, look at this. Okay, we want to determine the domain of each function. So g of t equals t minus 2 over t squared minus 3t minus 10. This is a rational expression. That means, okay, we always need to find those t values that makes the denominator 0, right? This one cannot be equal to 0, right? So domain is all real numbers except these t values that make the denominator 0. So let's find out what t value make the denominator 0. Okay, let's the denominator equal to 0 so that we can find t. So how do you find t value? Okay, we can use the factoring, right? So negative 10 is 2 times 5. 2 times 5 is 10. We need negative sign, so let's put it here. Then t squared is t times t. Then the cross product is 2t, and this one is negative 5t. Then the sum is negative 3t. So this sum is same as the second term. So this trinomial is a product of t plus 2 and t minus 5. That is equal to 0. So by setting each factor equal to 0, t is negative 2 or t equals 5, right? So as you see this, t can be any real number except these two, negative 2 and 5. So the domain is all real numbers except what? Except t equals negative 2 and 5, right? Make sense? All right, then let's try the next one. The next one is square root. So f of x equals square root of 4 minus x squared. All right, square root. Do you remember the restriction? Always, if you have a square root, then always the expression inside the square root has to be what? This one has to be greater than or equal to 0, right? This one has to be greater than or equal to 0, right? So let's find out what x is. Okay, so we will set the expression greater than or equal to 0 and then solve for x. So from this one, we can factor this one, right? This is 2 squared minus x squared. Do you remember? A squared minus b squared. Then we can factor this as a plus b, a minus b, the difference of squares, right? So this is 2 plus x, 2 minus x, greater than or equal to 0. So in order to find the interval that makes this inequality, we can plot the x-intercept, right? So x equals 2. In this case, x equals negative 2 and 2. And then find out the sign of y for each interval. So if x is less than negative 3, negative 2, so let's use x equals negative 3. Okay, negative 3. Okay, this is interval 1, interval 2, interval 3. And for each interval, let's find out whether y is positive or negative. So if x is negative 3, then the first factor is, okay, this factor is negative, right? Negative times this factor is also negative. So the result is positive. So this is positive. And the second interval, so let's use x equals 0. Then as you plug in 0, then that is positive. Plug in 0, then this is negative. So the result is negative. So this interval contains negative y value. How about the next interval? So let's use number 3. You can use any number in the region, in the interval. So if x equals 3, then the first factor will be positive. The second factor will be also positive. So the result is also positive. So we are looking for the positive part, right? Greater than or equal to 0. So we can also include -2 and 2 as well. So we are looking for this. So these intervals are solutions, right? Solutions. I mean, it's not solutions. Actually, these are the domain. Can you see it? Okay, wait a second. Okay, I made a mistake. So, okay, this is not right. This is not right. I made a mistake. All right, let's try it again. Try it again. Okay, if x is -3, then this will be negative, right? Negative. And -3, then this is 2 minus negative is positive, right? Positive. So that will be negative sign. So this interval will contain a negative sign. And if x equals 0, then this is positive. X equals 0, then also positive. So the result is positive. Okay, if x equals 3, then 2 plus 3 is positive times 2 minus 3 is negative, right? So that is negative. Negative. So we are looking for the positive part. So positive part is what? Between 2 and -2. And also since there is equal sign, there's equal sign, so we will include the endpoint. So this is the domain, right? Domain. So the domain is what? X is between, so x should be between -2 and 2, including the endpoint. Can you see it? All right. Okay, next example is, okay, a of s equals s squared, and a of s is the area of a square. So if you have a square, then each side is, in this case, side is a, side length is s. So the area is s squared, right? This is the area. So as a common sense, the area cannot be a negative number or even 0, right? Because s is greater than 1. So, greater than 0. So s is a length, so cannot be 0 or cannot be a negative number. So isn't it, as? So s has to be what? Greater than 0, right? It cannot be a negative number or 0. And then goes, so s has to be greater than 0, right? 0. So in interval notation, the domain is s is greater than 0. Okay, that's it. Or you can write it as, okay, starting from 0 to infinity. S can be any positive number. So that's the domain, right? Domain. So domain is the input values of s. So s is, the length is greater than 0, greater than 0. Okay, now graph the function and state the domain. Okay, this is a linear equation. So for the linear equation, we can plot 2 points. We can find 2 points. So if x equals 0, let's find f of 0. Then 2 times 0 minus 3 equals -3, right? So if x equals 0, then y is -3. And also we can find any number. Let's find out x equals 1. So f of 1, let's find f of 1. Then 2 times 1 minus 3 equals -1, right? So if x equals 1, then y is -1. So that we can connect these 2 points. So that's the graph. And then domain. What's the domain? Domain is all real numbers, because there's no restrictions. All right. So when we graph it, we can write a table, x value and y value, so that something like this, x value, the input value, and then based on this input value, you can find the output. So if x equals 0, then plug in 0, so minus 3. X equals 1, then that's negative 1. X is negative 1, then what? Negative 5, right? If x equals 2, then 4 minus 3 is 1, right? So we have an order pair, negative 1, negative 5, 0, negative 3, 1, negative 1, and when x equals 2, x equals 2, y equals 1, x equals 2, y equals 1, and so on. So you can plot all these points, then connect those points, then it will form a straight line. Okay, there's another one, g of x. Let's graph this one. This is a cubic function, a square function. Okay, if this is a square function, then this is quadratic. So the graph looks like opens upward or opens downward. But in this case, 2 is a positive number, so the graph is this one, okay, not this one. All right, so keep in mind the graph. So we can find some order pair by giving an input and output. Giving an input and output. So let's try when x equals 0. So 0 means 0 minus 3 is negative 3. So we can graph it, x equals 0, then y is negative 3. Okay, let's try x equals 1. X equals 1, then 2 minus 3, so that's negative 1. Negative 1 over here, right? How about x is negative 1? Negative 1, then still 2 minus 3, so that's negative 1. So x is negative 1, then y is negative 1 over here. Let's try one more, x equals 2. X equals 2, then 2 times 2 is 4, 4 times 2 is 8. So 8 minus 3 is 5. Then it will be 5. Let's say 1, 2, 3, 4, 5. It's going all the way up. Even negative 2 is also 5, right? 8 minus 3 is 5. So the graph, the graph looks like opens upwards, so we can graph it. Connect these points smoothly. Connect smoothly like this, right? And then the domain. In this case, for the domain, there's no restriction. X can be any real numbers, right? So domain is all real numbers. All real numbers. Okay, h of x equals 2 square root of x minus 3. This is square root, so we know that, keep in mind, this is greater than or equal to 0, right? Cannot be a negative number. So keep in mind that x is greater than or equal to 0. All right, so let's find out some order pairs. So h equals, y equals, doesn't matter. So if x equals 0, then 2 times 0 is 0, so negative 3. Okay, so x equals 0. X equals 0, then y is negative 3. 1, 2, 3, right? Okay, x equals, this time let's use 4, because, in order to remove the square root, we need the square inside, the perfect square number, so 4. If x equals 4, then 2 times 2 is 4, so 4 minus 3 is 1. So 1, 2, 3, 4, then yx equals 1, right? Over here. If x equals 9, let's try 9. Then 2 times 3 is 6. So that will be 3, right? So 4, 5, 6, 7, 8, 9. Let's say this is 9. Then this will be 3 over here. How about negative 4? Negative 4. Look at this. 2 square root of negative 4. This is not a real number, right? Not a real number. So we cannot have x, negative value for the x. So the graph looks like what? This one. The square root graph. Do you remember square root graph? Like this. Okay. Like this. Okay. So the domain. So domain is x has to be greater than or equal to 0. So domain comes from this radicand, the expression inside the square root. Okay, now let's get from this one, let's find the value of f of, okay, f of 4. Okay, first we want to find f of 4. That means the input value is x, is 4. So replace x with 4. But as you see this, there are 3 different expressions. And these expressions depends on the input. So as you see it on the right side, okay, if x is 4, then 4 belongs to where? 4 belongs to the third one, this one, right? X is greater than 3. So whenever the value is greater than 3, then we will use this function, this expression. So we will use the third expression because the input value x is 4. Okay, 4 belongs to the third one, right? Third one belongs to this interval. So we will use this expression. So replace x with 4. Then this is equal to negative 8 plus 15. So the value will be 7, right? Okay, let's try another one. Find f of 0. Okay, f of 0 means, okay, the input value x is 0. So 0 belongs to where? It belongs to here. So we will use the second expression. So f of 0 means we will use x squared, which is 0. Okay, let's try another one, c. Okay, that is f of negative 3, f of negative 3. Okay, negative 3, the value x is negative 3. Okay, this means the value x is negative 3. So negative 3 belongs to where? This one. So we will use the first expression. Okay, so that is replace x with negative 3. So that will be 3, right? 3. Okay, now letter D is graph. It says to graph it. Okay, graph the function. That means, we have a x interval. The x intervals are different. X intervals different. So if x is less than negative 2, then the graph is x plus 6. So y equals x plus 6. This one, okay, the x value, the domain for this one is negative infinity to negative 2, right? But negative 2 is not included. So for this interval, let's find the graph of x plus 6 is this one. Okay, if x equals negative 2, okay, what happens if x equals negative 2? Then negative 2 plus 6 is 4, right? So if x is negative 2, then y is 4. 1, 2, 3, 4, for example. This is 4. All right. And the graph is a straight line. It's going something like this. It's going like this. Straight line. Okay? So you don't have to extend it. You don't have to extend it because the graph stops at x is negative 2. So we don't need this one. Okay. And then if the x interval, if the x is between negative 2 and 3, 1, 2, 3, between these two x values, then we will use x squared, right? X squared. So we will use y equals x squared. Okay, this is the first interval, and the second interval is, let me go over here. So the second expression is y equals x squared if what? If x is between negative 2 and 3. So if x is negative 2, then what is this value? The y value is 4, right? 4. So if x is negative 2, then y value is 4. Let me use a different color. So that will be and this one, right? And then if x is 3, then 3 squared is 9. So if x 3, then let's say 9 is all the way up. So let's say, okay, let me write it reasonably. All right, so okay, let's say this is 9. Okay, so 4, 5, 6, 7, 8, 9. Over here, right? So this point is included. And then if x equals 0, then f of 0 is what? 0 squared, so it's 0, right? It's a 0. So this one is a quadratic equation. The quadratic equation is this. And it's something like this. Okay, so it stops here. The graph stops here because the x value is starting from -2 to 3, and 3 is not -2 is not included, so I'm going to use an open circle. All right, then from here, the third one is y equals -2x plus 15. So if x, the interval of the input is greater than 3, then we're going to use this expression. So f of 3, what is f of 3? Then -2 times 3 plus 15. So -6 plus 15. So that is 9, right? So let me use red this time. So if x equals 3, then it will be 9. So I'm going to put like this. And then this is negative. So as x increases, this one goes down. Straight line. Okay. Straight line. So the graph looks like this. So this is interval 1, this is interval 2, this is the graph for the interval 3. Okay, so we want to find the value of a. A is an x value. I don't know what this a value is, but f of a is equal to 2. So just replace this one. So if you replace x with a, okay, this means x value is a, right? So let's replace x with a. So f of a, so replace x with a, then this will be, the expression will be a squared minus x minus 4, right? So not, okay, where is, this one is a, right? A. So that is a, right? A. And then f of a is given. The value of f of a is 2. So replace it with 2. And then a squared minus a minus 4. So from this one, we can find a, right? A. Because, from here, already f of a is given. The value is given. All right, then from this, let's find a by factoring. So why don't we move minus to each side, right? Minus to each side. So 0 equals a squared minus a minus 2. Minus 6. Okay, then we can factor this trinomial. A times a, 6 is 3 times 2, and then negative sign goes 3. So that this one is negative 3a. This product is 2a, then the sum is negative a, right? So this sum is same as the term in the middle. So we can rewrite it as a product of a minus 3 and a plus 2. Since the product is 0, we can set each factor equal to 0. So we found two values, a equals 3, and from this one, a equals negative 2, right? So we found two a values. Okay. Okay, there's a definition of zeros of a function. Okay, zeros of function means, okay, set the function equals 0. So since the function is 0, we can find x, right? We can find x. Then these x values are the zeros of the function. Okay, so these x values are what? X-intercept. So zeros of the function means find the x-intercept. So how do you find the x-intercept? Set the y value equal to 0, right? So same meaning. The zero of the function is this one. So let's say there is a graph. Just an example. The graph looks like this. Then these are the zeros of the function. Sorry. These are the zeros of a function. All right, zeros of the function. So zeros of the function means find the x-intercept. How do you find the x-intercept? Set y equals 0, and then solve for x. All right, so we want to find the zero of the function. So what we're going to do is make the function is 0. So I'm going to make this function is equal to 0, right? So set f of x is equal to 0. That means this trinomial is equal to 0. So let's find x. Okay, we can factor this one. So 1 times 3 is the minus goes here, so that the result will be negative, right? Negative 2x. So the left side is x plus 1 times x minus 3. So from here, set each factor equal to 0, so x equals negative 1 and x is 3. So these are the zeros of the function, which is the x-intercept of the function. Okay, state whether the graph is the graph of a function. Okay, if a graph is a function, then always draw a vertical line test. Draw a vertical line. So we can try, we call it vertical line test. Vertical line test. Okay, this means if the vertical line has only one intersection, then that is a graph. That is the function. Okay, so one intersection, then the graph is function. Okay, so draw this one. Draw a vertical line on the graph. This one has three intersections, right? Three intersections. So this is not a graph of a function, not a function. Okay, this is not a graph of a function. Okay, how about the next one? Now, as you draw a vertical line, it has only one intersection, right? Only one intersection. So this is the graph of a function. Can you see it? The function. Because this one has only one intersection on the graph. Okay, let's check if a function is increasing. Okay, function is increasing on an interval means, okay, as you see the graph, as you go to the right, x increases, then the y value increases. So from here to here is the function is increasing because when the value, let's say this is the x value. So based on this, as x approaches a from the left, the y value gets greater. Then we call this is increasing in this interval. How about this one? Also from here it's going up, right? Going up. As x increases, the y value increases. So this part is in this interval, the function f is increasing. We call it increasing. How about decreasing? Okay, decreasing means as x increases, the y value now decreases. So starting from a and then going down, right? Going down. So this graph is f is decreasing from a to b. Let's say this is b. Okay, b. All right, and let's say this is c. How about constant? Constant means, as x increases, y value is always the same. Okay, y is always the same. So this is constant. Okay, this is constant. So f is now constant. All right. Okay, so the blue part is increasing. Okay, the blue part is increasing. This is increasing. And the red part is decreasing, right? The function is decreasing on the x interval. And 3 is constant. The function is constant in that interval. Okay, now one-to-one function definition. Okay, if a function is one-to-one, then when you draw a horizontal line, then the graph should meet at most once. So the intersection must have only one. So for example, let's say here is a graph, something like this. Here's a graph like this. Here's a graph, let's say this one. This is y equals x squared. And this is y equals x cubed. Something like this. So let's draw a horizontal line. So as you draw a horizontal line, then there's one intersection, right? So if the horizontal line has one intersection, at most, 1. Okay, 1. Then this is a one-to-one function. This is one-to-one function. Okay. How about the second graph? Okay, this graph, once you draw a horizontal line, this one meets at two intersections, right? So in that case, this is not a one-to-one, not one-to-one function. Very simple, isn't it? Very simple. So one-to-one function means if there is a value, then the y value cannot be equal to the same, cannot be the same. All right, so just draw horizontal line. If it has one intersection, that is one-to-one function. Okay, now the definition of the greatest integer function. Okay, this means the function is written as something like this. The symbol is different. Here is x, variable x, and then we have this symbol, and then also double square bracket symbol and int parenthesis symbol. So this means these symbols all meaning the same thing. So the greatest, as you see the title, greatest integer. So look at this. Here's a number line, and then this is 0, this is 1 and 2. So if there's a number like let's say, okay, I'm going to use the same symbol, okay, 0.2, then 0.2 is not an integer, right? Not an integer. So we want to find the greatest integer that is equal to this number and less than this number. So since 0.2 is this one, the smallest integer, the integer that is greatest is 0, isn't it 0? So the answer will be 0. So if you have 0.99, then the integer that is less than or equal to this, and the largest integer is what? So if you are here, then the integer will be, the integer that's less than this one is what? 0, right? 0. Okay, so any number between 0 to 1, okay, 0 is also, 0 is of course 0. 0 is 0 because 0 is the integer, right? Integer. So 0 is 0 and 0 point something is always 0. Always 0. Can you see it? And then if it is 1, then what? Then 1. So 1 is an integer. So if x equals 1, then the y value will be 1, right? 1. Okay, something like this. Can you see it? So look at this one. 0, 1, 2, 3. So 1, 2, 3. So if x is 0, then y value is 0. X is 0 point something, then it's always 0. Right? If x equals 1, then I will put an open circle. So open circle means it's a whole. So 1 is not included. So if x equals 1, then y is 1, right? 1. How about 1.2? Then 1.2 is what? 1.2, the greatest integer is 1, right? So if x is between 1 and 2, then the y value is always 1 until it becomes 2. So if x equals 2, then of course y equals 2. So if x is between 2 and 3, then it is always 2, right? And so on. So this one can be also used as, also written as, called as a floor, floor function. It's like a floor, stairs. Okay, how about this one? -1 and -2. If x is between -1 and 0, then the greatest integer is what? -1 is -1. -1, right? So if x is -1, of course -1. And if x is between -1 and 0, then the graph will be -1. Can you see this? Okay, if x is -2, then of course the y value is -2. But if x is between -2 and -1, it is always -2, and so on. Can you see it? Okay, so this is called greatest integer function. Okay, now C of x is the cost of parking. So in certain x hours. So let's evaluate C of 2. So C of 2 is just plug in 2 for x. So 3 minus 2 times, okay, int means what? Find the greatest integer, right? Greatest integer that is equal to this number or less than this number. Alright, so plug in 2. Okay, then this is equal to 3 minus 2 times. Okay, what is this one? Integer, greatest integer of negative 1. Okay, negative 1 is negative 1, isn't it? It's an integer, so 3 negative 2 times negative 1. So that equals 3 plus 2 is 5. So the cost will be $5 if you park for 2 hours. Okay, let's try when x is 2.5. Okay, then 3 minus 2 times greatest integer, and then 1 minus 2.5. So 3 minus 2 times, okay, this is 1 minus 2.5 is negative 1.5. Look at this. Here's negative 1, negative 2, negative 1. Negative 1.5 is over here, right? So the greatest integer is negative 2, isn't it? Negative 2. So 3 minus 2 times negative 2. So 3 plus 4 equals 7. So if you park $2.5 hours, then you need to pay $7. So always, if you're not sure what this value is, then find the 2 points that contains this point. So negative 1.5, this is negative 1.5. So negative 1.5 is between negative 2 and negative 1. So the greatest integer is what? Negative 2, right? Okay, now let's graph this cost, the price function. All right, so okay, let me find out x. Okay, here, let's set the x. So, the x interval, greatest integer function is always, okay, this is number of hours. So number of hours, x is greater than 0. So let's make it a 1 interval. So let's say x is greater than 0 and the less than what? Less than or equal to 1. Then let's see what happens. Then the C of x equals 3 minus 2 times integer 1 minus x. So let's find the C value. So if x is between 0 and 1, then what is this value? 3 minus 2 times 0 and 1. Then this value is, isn't it 0, right? 0. So the answer will be, the y value will be 3, right? 3. So from 0 to 1, then the value will be 3. So this is 3, right? This is 3. So starting from here, go all the way up to here. So if x equals 1, then this is 0, right? 0, so 3. Okay, so if x is between 1 and less than or equal to 2, then what happens? So 3 minus 2 times. So 1 minus 2. Okay, look at this one. Integer 1 minus 2 is, okay, look at this. So let me write it. Integer 1 minus 2, right? 1 minus 2. All right. So the x value is less than 2, little less than 2, 1 point something, right? 1 point something means this will give you, okay, that is, what is the integer? 0 point, so 1 minus, this is 1 minus 1, let's say 1.9. Then this will be negative 0.9, right? 0.9 is equal to what? Negative 1, right? Negative 1. Because look at this. Here's a 0. This negative 1. 0.9 is over here. So the greatest integer is negative 1. So this one is 3 minus 2 times negative 1. We're using, okay, instead of using 2, let's use 1.9. This is much better, right? Okay, so that equals 3 times 2, which is 6, right? 6. So if x is between 1 and 2, then the value will be, okay, look at this, we're not multiplying it. Okay, this is plus 2, right? So that is 5. So between 1 and 2, the value will be 5. This is 5. So here, right? And then when x is equal to 2, it becomes 5. So as we keep doing this one, okay, let's do one more time. If x is between 2 and 3, then the c of x will be 3 minus 2 times integer. Okay, 1 minus, let's use 2.9. 2.9. Then this is 3 minus 2 times what? Okay, here it is integer 1 minus 2.9. Then this is equal to int negative 1.9, right? So as you see this, here's negative 1, negative 2. Negative 1.9 is here. So the greatest int is negative 2. So this will be negative 2. So 3 plus 4 is 7. So now, if x is between 2 and 3, there will be 7, right? This is 7. So here, 7 and all the way to number 3, like this. Okay, so we can keep doing this for others. So it will be, next will be what? 9, right? 9. So between 3 and 4, it will be 9. And then go all the way to 4, like this. And keep going like this. Okay, keep going. So that's the graph of this greatest integer function. Okay, example 10. Okay, we want to find the value of a car. So the initial price of the car is $16,500. And then every year the car's value decreases by $2,200. So if t years passed, then the total decreased value will be the product, right? Product of $2,200 times the number of years, right? So we want to find the value of the car after 3 years. So isn't it? Okay, let's say the V of t. V of t is the value of the car after 3 years, after t years. So the original price was $16,500. Then every year it decreases by $2,200. So we will multiply this by the number of years. That makes sense, right? So we just set up an equation like this. So the initial price minus the depreciated value every year. And the depreciated value after t years is the product of 2,200 and the number of years. So 3 years, after you purchase the car, so we need to plug in t, 3 for t. So 2,200 times 3. So that is 6,600, isn't it? Minus 6,600. So it will be $9,900. So the car value after 3 years will be $9,900. Okay. Okay, next example is this. A ship is going east with the speed 7 miles per hour for t hours. Okay. So actually the distance that the ship traveled is what? The distance is speed times the number of hours, right? So the speed is 7 hours, 7 miles per hour, so 7t. So this is the distance that the car traveled. The ship traveled, right? All right. The distance, I better use a distance. Okay. So we want to find, okay, here's the lighthouse. We want to find the distance from the lighthouse to the ship. After the ship traveled t hours. So in that case, we need to use the Pythagorean theorem. Do you remember Pythagorean theorem? All right. So let's say this is the right triangle ABC. Then C equals square root of A squared plus B squared, right? Okay, before this one, we know that C squared is A squared plus B squared. We want to find C, so take a square root on the right side. All right, so based on this Pythagorean theorem, we can find D. So distance. The distance equals what? Distance is a function of t, isn't it? Function of t. So can we write it something like this? The distance depends on the ship traveled, right? Depends on the number of hours. So t of t, d of t, let me use d of t. So the distance after t hours is what? Take a square root and then square each side. So 2 squared is, so 70 squared plus 4 2 squared, right? So that's the expression for the finding the distance between lighthouse and the ship after t hours. Then simplify this square root expression, then that is 49 t squared plus 4. So this is the equation. So that, if you plug in t value, then you get the distance right away. Okay, now I'm gonna cut a rectangular paper to make a box. So we will cut it, x inches from each corner. Okay, from each corner. Okay, let me draw this one. So this one is x inches, x inches. Even this one is x inches. So here this is x and this is x. So we're gonna cut like this. Okay, I think I made a recording, without I did a recording, when I solve this exercise 12. Okay, let me explain it again. Okay, so we have a rectangular paper, and we want to make it a box by cutting the corner, 4-side corner, and each side is x. Let's say x inches. So each side is 40 inches. So there are 2 x's on the left, on the right. So the length will be, once you make a box, the length will be 40 minus 2x. And the width is also same as 40 minus 2x. And then from this one, the volume. The volume is length times the width times the height, right? So each length is 40 minus 2x, and the width is also same, so we can make a square, and the height is x. So the volume can be written as this expression. And the domain means the values of x, right? The interval of x. And x is the length of the corner. So the length of the corner has to be greater than 0. And then also it cannot be half the length. So 40 divided by 2 is 20. So x is always 0, between 0 and 20, not inclusive. All right. That's it, right? That's it. This is not hard. It's really simple. Okay, then please try to understand what we learned today, and then we will go on to the next section.